In this video, I am going to discuss a problem where you have to apply Leovelas theorem. My problem is prove that the complex plane and the unit disk D are not conformally equivalent. So that means we have to prove that there does not exist a conformal map F from complex plane to unit disk. This is what I have to prove. I hope you are familiar with the term conformal map. If is said to be conformal, I will write down the definition. If is said to be conformal, if it is analytic, in this case analytic on C, in generally I'll write analytic and one to one, right? So if you have some domain and if your function is analytic in that domain and if it is one to one in that domain, we will say that F is conformal in that domain, right? F is conformal in that domain. Okay, so in this case I am going to use the method of contradiction to do the proof, right? So I will start the proof, right? So this is what I'm going to do. So my target is to show that there does not exist a conformal map from complex plane to the unit disk. So to the contrary, I will assume there exists a conformal map from complex plane to unit disk, right? This is my hypothesis, right? So I'm assuming that there is a conformal map from C to D, and I will call that conformal map as symbol F, right? So suppose that map is symbol F and F is from C to D, right? So F is analytic in C and it is one to one, right? Because it is conformal, right? Okay. Now what can you say about its range? It does not matter what value that you are going to input, you would get some value in unit disk. Therefore, I can state that the modulus of Fz is less than 1 for every z in C, right? So for any z value that you choose from your complex plane, your function value is going to be the modulus of your function value is going to be less than 1 because your image is uh, inside the unit disk, right? Okay, now I can use the Leovelas theorem. So what does Leovelas theorem say? So Leovelas theorem says that Leovelas theorem says that if we have a bounded entire function then that function should be a constant function. Okay. Now, in this case, our function simple f, it satisfies the conditions of Leovelas theorem because it is defined in the whole complex plane. So, therefore, it is entire, and also it is bounded because whatever the value that we are going to input, our image is contained in the unit disk. So, in this case, in our case, f is entire and bounded. Hence, by the Leovelas theorem, f is a constant. So I will call f is equal to k for every z in complex number plane. Right? Right. Now, according to our assumption, f is analytic and one-to-one. Right? F is analytic in C and one-to-one. Now we got a result that f is equal to k. That means whole complex plane is going to map to the to some value inside this unit disk, right? So the whole complex plane will be mapped to this point, right? Okay, so every value is going to be mapped to this k. So this would say that f is not one to one, not one to one. So this leads to a contradiction because according to our assumption, f is analytic and one to one, but according to that assumption, we continued our proof and we got a result which says that f is not one to one. So this is a contradiction, right? Therefore, we can conclude that there does not exist a conformal map from complex plane to unit disk, right? I hope you understood what I did here, right? This is a good example, uh, a good application of Leovelas theorem, right? Okay, I'm going to stop the recording from this point and thank you all for watching.